Welcome back to our video series on electrochemistry. We are picking up with redox chemistry and looking at balancing redox equations with the half reaction method. So there's this list of steps and you do want to follow it step by step, and so we're going to go through some examples, but just to give you a heads up, the first step is to split up the reaction into two half reactions, your oxidation and your reduction half reactions. Once you do that, you're going to balance each half reaction for all of the elements except for hydrogen and oxygen. We leave those two for last because when we balance the oxygen, we're going to add water molecules. And then when we balance the hydrogen, we're going to add hydrogen ions, that H+. Once all the elements are balanced, then we'll go back and add electrons to balance out that charge. And then if necessary, we can multiply one or both half reactions so that the number of electrons for each half reaction match, and they have to be on opposite sides. Then we'll add those two half reactions together, cancel anything out that we can on both sides, and simplify. And if we are in a basic solution, then we have to add hydroxide ions. We're going to add those hydroxide ions to the side which has the hydrogen ion, and those can mix together to produce water molecules. But whatever we add to one side of the reaction, of course, we have to add to the other side. And so if we add a hydroxide to one side, we'll add that same number on the other side, and then simplify from there. Okay, so the best way to do this is to practice. So first we're going to start with just balancing some simple half reactions, and then we'll look at the whole thing. So in our first example, we have 10 with a +4 charge and 10 with a 2 positive charge on the product side. So in this example, we have the same number of 10s on either side, right? The coefficient is the same on the reactant and the product side. There's no oxygen or hydrogen to worry about, and so the only thing we need to do here is balance the charge. So we're on step 5, where we balance the charge by adding electrons. Okay, so you want to pick the side that has the larger charge, which in this case is the 4+, and that's because electrons carry a negative charge, so they're going to decrease whichever is the larger side. And we need to decrease that 4+ till we get down to 2+, and so we need to add 2 electrons to the reactant side. And that's really all there is. Okay, for that first one. Now in the second example, we have oxygens present. So again, our first step is to balance everything except for oxygen. And the manganese, we have 1 manganese on either side. So that's balanced. Then we focus on the oxygen by adding water molecules. So if I have 4 oxygen atoms on the reactant side, I will balance it on the product side by adding 4 H2O. 4 water molecules. And water will have the phase of a liquid. Once that's done, we'll balance the hydrogens next. And remember, we balance the hydrogens by adding that H+ ion. Okay, so oxygen first with the water molecule, then hydrogen next with the H+. Okay, so when I added the 4 water molecules to the product side, that gives me a total of 8 hydrogens on the product side, and so I have to add 8 hydrogens on the reactant side. And those hydrogen ions will always be in the aqueous phase. And then the last step is to balance the charge. So if I want to balance the charge, I add up all the charges on the reactant side. So I've got 8+ coming from the hydrogen ions plus a -1 coming from the permanganate ion. And then on the product side, I've got just the 2+ charge coming from the manganese ion. So overall, I've got a +7 on the reactant side versus a +2 on the product side. And the larger side, of course, with the +7, you'll need to add 5 electrons to that side to balance it out to get you down to +2. Okay, and we can rewrite this reaction out just to clean it up. We've got 8 hydrogen ions in the aqueous phase plus 5 electrons, and our permanganate ion, MnO4 negative, and that yields the manganese ion plus 4 water molecules. And the manganese ion was also in the aqueous phase. Anytime you have a charge, that will be aqueous. Now let's try looking at a whole reaction and balancing it in acidic solution. If they don't tell you one way or the other, assume it to be acidic solution. First step, of course, is to split it up into your 2 half reactions. Okay, so you want to use the center of your paper, take that first element on the first compound or ion on the reactant side. That's our cyanide ion, Cn negative, arrow, and then find the product for that oxidation or reduction half reaction. And so we've got the carbon and the nitrogen on the product side as well. CNO. And then add a little bit of space in front of each side so that you can add your coefficients. Now, the other half reaction that we have is our chlorine dioxide, so ClO2. And notice how I'm ignoring the phases right now. It's best to leave those out until the end. And then on the product side, we have that chloride ion. Okay, so once we've split up into our 2 half reactions, the next step, remember, is to balance each for all of the elements except for hydrogen and oxygen, and then we'll focus on oxygen next. So all the carbons, nitrogens, and chlorines, you can tell those are already balanced, and so the next step is to look at that oxygen. Now, we have 1 oxygen on the product side in the first half reaction, so we're going to add 1 water molecule on the reactant side. Leave some space in case we need to change that coefficient. Let's do the same for the second half reaction. We've got 2 oxygen atoms on the reactant side, so we need to add 2 water molecules onto the product side. Now that the water molecules are balanced, we're going to go back and balance the hydrogens next. So on the reactant side, on our first reaction, we've got 2 hydrogens, and so we need to add a 2H plus on the product side. And then for our second reaction, we've got 2 water molecules, so that's a total of 4 hydrogen ions that we'll add to the reactant side. Okay, our oxygens are balanced, our hydrogens are balanced. The next step is to balance the charge. So overall, for the top reaction on the reactant side, we've got a 1 negative charge coming from that cyanide ion. And then on the product side, we've got that 1 negative plus we've got 2 hydrogen ions for a total of a 2 positive charge. Okay, so -1 plus 2. We've got a 1 positive charge on the product side versus a 1 negative charge on the reactant side. So we pick the larger of the 2, and we need to decrease that down until we get to the charge on the reactant side. And so we're going to need to add 2 electrons, right? Because +1 plus a 2 negative would give us back that -1 to match the side on the reactant side. Okay, let's do the same thing for the second reaction. We've got a 4 plus charge coming from the hydrogen ions on the reactant side. And then on the product side, we just have that 1 negative charge coming from the chloride ion. And so, of course, the reactant side is larger with a +4, and we need 5 electrons to get it down to a -1 to match that product side. So we need to add 5 electrons to the larger side, to the reactant side. Okay, now that we have balanced all of the elements and the charge for both half reactions, the next step is to multiply one or both half reactions so that the number of electrons are the same on either side. And so right now we've got 2 electrons on the product side in the first reaction, 5 electrons on the reactant side in the second reaction. We need those to match. And so of course the least common multiple, or the least common multiple will be 10 there, right? So 2 times 5 to give us 10. That means the first reaction I've got to multiply by 5. And so we've got to distribute that 5 to everything. We get 5 waters, 5 cyanide ions, 5, and then 5 times 2, that will cancel to give us 10, and then 5 times 2 cancels to give us 10. And then everything on the second reaction we've got to multiply by 2. Okay, so again that becomes 10 electrons, 8 hydrogen ions, and then 2, 2, and 4 water molecules. Okay, the next step is to add up everything and cancel out anything that's the same on both sides. So depending on how you feel, you might need to clean this up before you do that. But I can see that I should have the same number of electrons on both sides of the reaction. And so those will cancel out. Okay, also the hydrogen ions, right? I've got 8 hydrogen ions on the reactant side here, and I've got 10 hydrogen ions on the product side here. So that 10 will cancel, and I will have 2 hydrogen ions left. So maybe I do need to stop and clean this up so we can see this better. We've got 5 water molecules plus 5 cyanide ions yields 5 CNO negative. We'll go back to that 10 hydrogen ions plus 10 electrons. Okay, and then in the second reaction we had 10 electrons plus 8 hydrogen ions plus 2 Alright, so just cleaned up there below. Now we can see those 10 electrons, those will cancel on both sides. The 8 hydrogen ions, those will cancel with most of the 10, right? That's going to drop down to 2 hydrogen ions left. And water molecules, so all 4 of those water molecules will cancel with all but 1 water molecule left on the reactant side. And so I can add this up. It will help to circle anything that's left over so we don't forget and miss something. That's why I had that 2 hydrogen ions. And so we get 1 water molecule, and let's go in and add those phases back. So that is a liquid water plus 5 cyanide ions. Again, anything with a charge will be aqueous, plus the 2 ClO2. That's aqueous. All right. So I think part of the trick here is just, again, knowing that process where you balance all elements first, except for oxygen and hydrogen. Oxygen with the water molecules, hydrogen with the hydrogen ion, then your electrons. Then make sure your electrons match on both sides. Clean it up as many times as you need to, and then cancel out and simplify. Okay, let's do one more. So in this example, we're going to balance in basic solutions. So that just means you've got one extra step at the end there. But we're going to start off the same way. So we're going to start off by splitting up into our two half reactions in the center of the page. That gives us aluminum. And then on the product side, there's only one product that has aluminum, and that's our aluminum hydroxide. Add those coefficients, or space for the coefficients in case. And then the second one, we've got the CrO4 2 negative chromate ion. And then on the product side, we've got a chromium hydroxide ion. Add some space for those coefficients. First step is to balance everything except for oxygen and hydrogen, and we see the aluminums and the chromiums are already balanced. So the next step is to look at that oxygen. So we have 3 oxygens on the product side, which means that we're going to need 3 water molecules on the reactant side. And then for the second reaction, we've got 4 oxygens on the reactant and the product side, so no need to add water molecules there. Go back and balance the hydrogens. So of course we have 6 hydrogens on the reactant side and only 3 on the product side, so we need to add 3 hydrogens to that first reaction. And for the second reaction, we've got 4 hydrogens on that product side, so we need 4 hydrogen ions on the reactant side. Okay, looking at the charges for that first reaction, there's no charge on the reactant side, and there's only a 3+ on the product side. So 0 versus 3+, of course 3+ is bigger, and so we're going to add 3 electrons on that product side. And then second reaction, we've got a 4+ charge coming from those hydrogen ions, plus a 2 negative charge coming from the chromate ion for an overall charge of 2+, versus a 1 negative charge on the product side. And so of course the reactant side is bigger by 3, so we're going to add 3 electrons onto the reactant side. So this time we have the same number of electrons in each half reaction on opposite sides, and so we can go ahead and just add those up as they are. So the 3 electrons will cancel, and then for the hydrogens, all 3 will cancel on the product side, and we'll be left with 1 on the reactant side. And then everything else should still be there, so we can write this out where we've got 1 hydrogen ion plus 3 water molecules plus aluminum and our chromate ion, and then our 2 products. Okay. Now, the last step, because we are in basic solution, we have to neutralize those hydrogen ions in a way. So if we go back all the way to our instructions here, right, if the reaction takes place in a basic medium, we're going to add those hydroxide ions to neutralize that H+ ion, and we've got to add it to both sides of the equation. So since I've only got one hydrogen ion on the reactant side, then I'm going to add 1 hydroxide ion to neutralize that, and I have to add it to the other side as well, onto the product side. Okay, now that hydrogen and that hydroxide will react to get 1 additional water molecule, and so total I will end up with 4 water molecules on the reactant side, all in liquid phase, plus everything else stays the same, right? We've got aluminum, our chromate ion, adding all those phases back in, and adding that hydroxide ion on the end. Okay, so that should end our review of redox chemistry. In the next video set, we will look at galvanic cells.